uh, 47. The problem number 47 says that x84y is divisible by 9. Find minimum value of x plus y. Okay, this is you have to find. So, and you know that any number, if it is divisible by 9, then the sum of that digit must be divisible by 9. So I will use the same formula, same concept we say. So if I add this digit, has to be divided by 9. So now these are two digits, x and y. I will keep it one side, and the remaining will 12 by 9. So now you see in the top it is 12 already, and it is more than 9. So the next divisible multiple of 9, which could be possible if x plus y, in case the minimum value of it if I take it is has to be 6. With the 6 it will turn into 18, and it will be divisible by 9 and get 2. So there is nothing is only thing is written is minimum value you need. So minimum for which then this number is to be divisible by 9 has to be 6. So this will be the answer. Okay, so moving on to the problem number 48. The 48 says if the product 4864 multiplied by 9p2 is divisible by 12, the value of p is how much? Okay, now if I do this, now as it is divisible by 12, I can write it like that, multiplied by 9p2 by 12. Now I try to represent this number in terms of 12. Let's see what I will get. It will be 12405 into 12 plus 4. Can I write it like that? Yes, I can write. 405 into 12, it will give you 4860 plus 4 remainder plus 9p2 whole divided by 2. Now if I divide this number in two parts, I will get this number divided by 12 into 2. So that means 405, 12 will be cancelled out. I will remain with 9p2. So you can see this number is definitely an integer, because whatever be the p value, this will be an integer, and integer multiplied will give you integer. So this part doesn't have problem. The remaining part, which will contain 4 into 9p2, has to be divided by 12. So this part, unless and until it is fully divisible, cannot be an integer. So if I reduce it, so further I can say this number has to be a divisible of 3. So up to this I can conclude. Then after I would work on the second part only, because first part have no problem because already an integer. So the second part says 9p2 has to be divisible by 3, then only it will be an integer. So what is the condition? The condition is that for being divisible by 3, 9 plus p plus 2 has to be divisible by 3. That means 11 plus p has to be divisible by 3. So this can be possible. And now one thing is that p as is a part of any number, it has to be a single digit number. That I can conclude, because it cannot be double digit, it is pressing inside a number. So up to what number p is possible, so that I can get, so p, this number has to be maybe I get 1, 2, 3, like that, any integer I'll get. So if it has to be 1, then this equivalent to this sorry, so this can be multiple of 3 for what value of p? If I take p is equal to 1 here, you can see it is 12. So 12 by 3, it is equal to 4, it is an integer. So p value can be 1. Let see whether any other value is possible or not. If I take p is equal to 4, let's say 4, then 11 plus 4, 15. 15 by 3 is a divisible, so p value 4 is also possible. This is also a single digit number, this one. Then next, p is equal to 7, 18. So this also gives you the integer. So p is single digit, is holds good. So these 3 values possible. Next, moving to the next multiple of 3 is, I will get when it is 21. So p has to be 10. So it is a double digit number. So p 10 is not possible. So up to this, whatever value got, it all are possible for p. Okay, so this will be your solution. In case there is an option is given here, in this case, in the question there is option given is 2, 5, 6 and 1. So what are the possibilities? The 1 is the answer. So if answer is given, you have to choose out of the answer. Otherwise, if it is a generalized problem, you can write all 3 answers. Okay. So moving to the number 49. Says 49 to the power 15 minus 1 is exactly divisible by some numbers are given by 50, 51, 48 or 19. Okay, or 19, it is a given. So what would be the case? To solve it, I have to establish some concept or formula. You can say any number a to the power minus b to the power n by a minus b, where n is equal to an odd number. Okay, in this case, this formula can be written as the highest power minus 1. From there I will start, and the next, as because both are negative, all terms will be added to the positive. A to the power, one term will reduce here, the next term of a, and there will be adjoining, there will be a b come, where b will come, and on the other hand, the next terms, that will reduce as it is by one term. This will be 2, this will be 3, and b will increase by a power. So like that it will go up to when a will be exhausted. I am writing the second last number. So it will be a b to the power n minus 2, and the last term it will be this one. This can be established by your similarity rule, because a square minus b square, a cube minus b cube, if I take a minus b, if I take, it will be a square plus ab plus b square. You can see it is 2 minus 1, 1, and there is at the end it is 2 will come here. So a square, one term reduce, 2 minus 1, 1 will increase. Here a will exhaust, 2 minus 2 means 0. It is nothing. So with that similarity, now a to the power 5, you will not get direct formula, but if I try to do it like that, let me multiply a to the power 4, let me take the, so this formula I will write it again. So to make you understand how it is coming, a to the power 4 plus a cube b plus a square b square plus a b cube plus b to the power 4. Now if I multiply all, I will get a to the power 5 plus a to the power 4b plus a square b a cube b square plus a square b cube plus a b to the power 4. Next, minus a to the power 4b minus a cube b a cube b square minus a square b cube minus a b to the power 4 minus b to the power 5. Now I see a to the power 5 this will be b to the power 5. Sorry, b to the power 5, there is no other terms which is similar, but a to the power a b 4 will be cancelled out. A square b cube, this is minus, and a square b cube plus a cube b square. So all terms cancelled out, remaining with a to the power 5 minus b to the power 5. So you can say that this term is nothing but equal to a minus b, taking this on the denominator. So this can also be proved. This can be proved for higher numbers. So now I can establish the formula where I said already that any number a to the power n minus b to the power n by a minus b, or you can say this is equal to a minus b a square a to the power n minus 1 plus dot 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 b to the power n minus 1. Remaining time I have already shown you. So this will be the case. So for this case, for the terms which is similar like this, where n is odd, this would be definitely a factor for this. So if this is the case, here a is equal to 49 if I take, and b is equal to 1 I take. So a minus b, that means 49 minus 1 will definitely be a factor for this. Now I am getting directly 48. Now let's say somewhere it has said that 48 is not there. Instead of that, it has given 8 and an option. So what would be your answer then? Then also 8 would be your answer. Why? Because 8 is a factor of 48. 48, whatever you get, 8 into 6. By this I also say that 8, as it is the factor of 48, so that 8 would be a factor of this also, or otherwise if 6 is an option. So all these combinations, so whatever be the factor of 48, 2 into 24, then 4 into 12, and 8 into 6, or any other combination, any other factor is which is a factor of 48 can be an option, and that will be your answer if the 48 is absent in there. Understood? So this is for today. In next class I will move on to 50th problem. Okay, thank you.